Hello everyone, and welcome to Grade 9 Algebra. My name is Carly Brockway. You can call me Mrs. B or even just Carly. I am from Canada. In Canada, I am a math and science teacher for middle school, and I think math is really fun. So we're going to have a lot of fun in this course. Now in this course, there are 14 chapters. So we'll be having to work very, very hard. So before we start to work on the first chapter, I'd like to go over some very important things in math. Now math is very, very, very practical. In fact, it's the language that is the basis for all other sciences. Now math, one trick for it is you need to practice. So although you might get the concepts immediately, go, oh, I understand, no problem. It really, really, really helps to practice, practice, practice. So practicing is very, very important in math. Make sure you keep up with all of the assignment questions. Now let's go on and talk about Unit 1. In the first chapter, what we're going to be covering is a variety of things. We're going to talk about the language of algebra, so the very, very basis for the rest of the unit, or the rest of the entire book. Now, also what we're going to be talking about is we are going to first of all talk about writing algebraic expressions. Then we are going to evaluate the expressions as well as solve open sentences, which we'll get to today. Then we're going to start to use algebraic properties of identity and equality. We'll start that topic today and we'll finish it next lesson. The next thing we're going to do after Chapter 1 is we're going to move on to conditional statements and counterexamples. The final part of Chapter 1 is to interpret graphs of functions and analyze data in statistical graphs. Well, it sounds like a lot of mumbo jumbo. Why is it important, really? Well, here's one example of why math is important. In every country and every place in the world, you'll find very unique and very inspiring architecture. Now, architects use algebraic expressions to describe the volume of the structures that they decide. So they use algebra when they're designing the buildings and all the structures around you. Now, a few of the shapes of these buildings can resemble a rectangle or a pentagon or even a pyramid. All right, so today's lesson, this is what we're going to cover. First introduction, which I just did. I introduced myself and what we're going to be studying in this unit. Then we're going to go on to the Chapter 1 overview, which we also just covered, the things that are all in Chapter 1. Next, we're going to go on to Section 1-1, in which we'll be talking about variables and expressions, followed by order of operations, open sentences, and then finally identity and equality properties. Now, before we get into Section 1-1, if you look on page 5 of your text, there is a Getting Started section. In this section, it goes over your prerequisite skills. Now, we don't have time to cover it today, but I want you to make sure you do it at home. There's things in there like find the product of 8 multiplied by 8, which is 64, very good. And other such examples. You need to find the perimeter, how long it is to get around a particular object, and you also need to find some products and quotients of some more complicated examples. So make sure you do the review section or the prerequisite skills on page 5 before you begin working on the assignment for this chapter. There's also a hint in there for you to make a study organizer in which you take a piece of paper, fold it, and then cut out the different sections. And that will really, really help you when it comes time to studying for the test, because you already have a list of terms as well as examples underneath each of those terms. All right, let's get on and talk about Chapter 1. Now on the board here, I'm going to draw a nice little rectangle or a square, and what do you think this is? Very good. It is a baseball field where you go play baseball. So here's the home base, and you've got first, second, and third. Now if I'm looking at this, I want to figure out the perimeter, how long it takes to get around. And I'm going to call the length of this side S, just because it stands for side. And I know that it's a perfect square, although it may not look totally perfect there. In a baseball field, it is a perfect square. So this would be S, this would be S, and this would be S. So 4 S's is what I want. Now another way to go about writing that is I could write 4S is equal to the perimeter of the baseball diamond. Now 4s is the same thing as 4 multiplied by s. But don't ever do that, and I'll tell you why in just 1 second. All right, so first of all, what we're going to do is we're going to practice writing some mathematical expressions. Look at it in your book. Now, as in the baseball field example, I used S to stand for the length of each side. Now, S refers to a variable. A variable can be any letter, A, B, C, D, E, F, G, any of those. It's just a symbol to represent something you don't know. I don't know how far it is. I'm going to give it a symbol. So that's what it's used. It's used to represent unspecified numbers or values. And any letter can be used. Now, an algebraic expression, so this is A, B, C, D, etc., A, B, C, D, E, F, G. The next part we're going to talk about is an algebraic expression. Now, an algebraic expression is just a combination of one or more numbers as well as some one or more arithmetic operations. So it uses numbers and variables and arithmetic operations like addition, subtraction, multiplication, or division. Here's some examples. Just to have a look, these are those same ones from your text. So we've got a number, a variable, a mathematical calculation. Now if you look at this one, 5x, it's similar to the 4s that we did in the baseball expression. And remember how I said that you never ever write x in algebra. And the reason why you never write x for multiplication is because let's go back a couple grades and you want to go 3 multiplied by 7 is 21. Well, in algebra, a variable can be any letter A, B, C, D, E, F, G. So you might think that this is actually a variable. 3x7 is equal to 21. And you really don't have any idea what that means. So don't ever use the multiply sign. Don't use the x sign. Instead, so don't ever do that. Instead, you can use a dot. So above example would be 3 times 7 is equal to 21. So 3 times 7 is equal to 21. Another way to write the same thing is by using brackets. So 3 times 7 is equal to 21. And these all mean multiply by. Don't use the x because you could start to confuse it. So that's just some ways to write multiply. We'll do it with variables now. X multiplied by y. It's not multiplied y, it's the variable x. X multiplied by y. Another way to write the same thing would be x multiplied by y, or x multiplied by y, same thing, or in brackets, same thing. These all mean this multiplied by this. All right, let's go on to the next section. Now, when you're multiplying things, the numbers or the quantities that are being multiplied are called factors, and the result is called the product. Now, in algebra, it's often very necessary to turn verbal expressions or speaking or written examples into algebraic examples when we're using the variables and algebraic expressions. Now, let's do an example. The first example in your text on page 6, it says 8 more than, it's got 8 more than a number n. Now if we look at this 8 more than a number n, this is the number 8. More than implies addition. So it's 8 more than a number n. You don't know the number, you don't know the value of it, so you just give it a variable, and we're going to give it the letter n because it says so there. So 8 plus n is equal to 8 more than a number n. Same sort of thing. This is the verbal expression or the written expression, and this is the algebraic expression. All right, let's do another example. This one I'm only going to say it, and I just want you to listen carefully. 7 less the product of 4 and a number x. Well, 7 less less the number means you take away or you subtract. So 7 less the number of 4 and a number x. So 7 less the product of 4 and a number x. So a product means it's multiplied because that's what we had said earlier. These are factors, and together it's a product. So you've got 7 take away 4 multiplied by a variable x. Also said as 7 less the product of 4 and a number x. Let's do one more practice. Listen carefully. 1/3 of the size of the original area A. 1/3 of the size of the original area A. In here, 1/3 is 1 divided by 3. Same sort of thing. It's a fraction. And 1/3 of the size. Now, of here replies or infers multiply. 1/3 of the size of the original area A. So 1/3 of A. There's a couple other ways to write the same thing. Remember, you can replace the multiplication by symbol by brackets. You could also go 1A over 3, or just simply A divided by 3. These are all the same thing. So those are some examples of turning verbal expressions into algebraic expressions. Let's get a little bit more complicated now. Now we're going to look at, here is our variable, and it's got a little small number up on top. Do you know what the name for this is? You're right, it's called a power. And the way that you would read it is you look at the base, which here is x, and you look at the exponent. So this is the exponent, and this is the base. The whole thing is called the power. Now the way that you would read it is, for example, this would be x to the nth power. Let's do a little bit more with actual numbers. So we've got 3 to the 1, and that is 3 to the first power. And what is, when you're looking at the exponents, it's just how many times this number is used as a factor. So this is equal to 3, which is equal to 3. Now, 3 to the exponent of 2, or 3 to the second power, is the same thing as saying 3 multiplied by 3, which is, very good, 9. Now 3 to the third power is also known as 3 times 3 times 3, which is 27. So that's how you refer to the exponents or to the powers in algebraic expressions. If you need some practice with that, there are several questions there for you to work on. Practicing working out those exponents or working out the powers. All right, let's go on now and talk about writing verbal expressions. Another important skill is translating the algebraic expression into the verbal. So for example, let's look at this one. 4 multiplied by m to the power of 3. That's one way you can say it. You could also say it's the product, because remember the product is when two things are multiplied together or two factors are multiplied together. So it's the product of 4 and what? Very good. And m, which is our variable, we don't know what m is, but m is to the third power. To the third power. Has an exponent of 3. So that's the other way to say the same thing. This is the verbal expression and this is the algebraic expression. The product of 4 and m to the third power. That's an important skill, especially when we're working out our problems. All right, let's go on now to the next section. So we've talked about variables and expressions, done. We've learned about variables, which are any letter to represent an unknown number, and we've also talked about some of the expressions, which is just a combination of a number or a variable with a mathematical equation like addition, subtraction, some sort of a symbol like that. Let's go on now and talk about the order of operations. Now the order of operations refers to step-by-step process. And when you're doing math, step by step by step is very, very important. Some people are able to just, boom, see the answer. But in order for us to work on to more and more and more complicated things, it's very, very important that you do each step for absolutely each question. So make sure you practice your order of operations for every question that you work on. Now, the order of operation means which order you do it in, which one you do first, which one do you second, and which one do you do third. Now, in your textbook, it refers to 4 steps. Number 1, evaluate all expressions within grouping symbols. Number 2, evaluate all powers. Step number 3, do all multiplications and/or divisions from left to right. And the 4th one is do all additions and/or subtractions, also from left to right. Now, there's an easy way that I actually learned in middle school to remember these, and it breaks the steps down into a little bit further steps. Bedmas, or bedmas, I don't know. It's an easy way for you to remember the order of operations. Now, B refers to brackets. So you do whatever in the brackets first. Now, if you remember from last grade, there are 2 types of brackets. You've got the small brackets and you've got the big brackets. Do the small brackets first, and then you do whatever inside the big brackets next. Now, E stands for exponent, but we'll refer to it as power. So you do everything that are, excuse me, or not power, grouping symbols. Grouping symbols. As exponents are just one version of grouping symbols, but it's an easy way to remember. So grouping symbols are next. Then we go down to division and multiplication. Now, these can be done in either order. It's just an easy way to remember, B-E-D-M-A-S, but it can be B-E-M-D-A-S. So they're interchangeable. The next one is addition, followed by subtraction. And the same thing with multiplication and division, they can be switched so that you're doing one or the other first. So this is your order of operations. Make sure you always follow it. Let's do some practice examples. Now, I'm going to erase this, but I'm going to leave the bedmas on so we can easily refer to it. The first example, let's try evaluating, is this one here. So we look at this entire expression. What do we want to do first? Are there any brackets? No. Are there any exponents or grouping symbols? No. Is there any division? No. Is there any multiplication? Yes. Let's do that right there. So we just carry this straight down. 3 plus 2 multiplied by 3 is 6. We carry this straight down. 3 plus 6 plus 5. Is there any more multiplication? No, we're done. Any addition? Yes. So 3 plus 6 is 9, plus 5 is 14. Very, very important that you follow through these steps. Let's do one more example, because this is probably one of the most important things that you'll learn to do in algebra. It's step by step by step order of operations. So the next one we'll practice doing is from your textbook on page 11, so you can follow through with me there. So first thing we need to do is look for brackets. Are there any brackets? No, no brackets. Next one, exponents or grouping symbols. Yes, we have one. So we leave everything else exactly the same, and we only do this one. Take away 4 squared, which is 16. Good. Are there any more exponents or grouping symbols? No, there's not. So now we can go on to division and multiplication, because remember, they're interchangeable. So 15 divided by 3 is 5, times 5 is 25. So we can do all those together. Now, if you want, you can break those down step by step also. Not a bad idea. So next we go down to addition and subtraction. Yes, there's one left. 25 minus 16, very good, is 14, or 9. Pardon me, is 9. So that is our final answer. Make sure you do it step by step, and you should always get that exact same answer. All right, let's go on now and talk about grouping symbols in terms of order of operations. So here's an example with the grouping symbols. Remember, when I use the brackets, it's the same thing as saying 2 multiplied by 5. Same thing. So 2 multiplied by 5, and we're going to add on to that 3 multiplied by 4 plus 3. So the first thing you want to do is look at the very top of your order of operations. B, are there any brackets? Yes, there's a bracket. Yes, there's a bracket. Then you need to evaluate all the expressions within the bracket first. So 2. Now 5 you don't need to do anything to because it's still 5. Then you're going to go on to 3 multiplied by 4 plus 3, which is 7. And then now we can go down to the next thing. So we've done within the brackets. Then we go to exponents. There's no exponents. Then we can do division and multiplication. So 10 plus 21. Now we can do the addition and subtraction, which is 31, our final answer. Okay, let's go on now and talk about a fraction bar. Now, a fraction bar is example 3 on page 12. And it looks like this. Now, you might get confused here because you think, there's no brackets, let's go on to the exponents. However, remember this one also stands for grouping symbols. And this type of fraction bar is a type of grouping symbol. Now, even though it doesn't show it, it's just the same thing as this. You must do what's on top, the numerator, and you must do what's on the denominator first before you can go any further. I want you to work through your chapter now or work through the example with the chapter on your own. So remember, you do what's on top first and then what's on bottom. All right, when you're evaluating algebraic expressions, there's often more than one operation. Algebraic expressions can be evaluated when the values of the variable are known. First, replace the variables with their values. Then, find the value of the numerical expression using the order of operations. So those are some practices you can do. I want you now to go on to page 13 where it's find the error. Now there's 2 choices. You've got Lori and Chase. I'll give you a hint for figuring out what the error is. Go through the order of operations and see what they did first. It has to do with the exponent in this case. So look at Lori and look at Chase and see which one did it wrong in the order of operations. I'll give you another hint. The answer is not 255. Why? All right, we're not going to have enough time today to go on to the rest of the section, so we will finish up with open sentences next. Make sure you do all the assignments and all the text questions and work through everything on your own. If you have any questions, make sure to ask the teacher who's helping you. Have a wonderful day, and I look very forward to seeing you next time. Bye-bye.